Hello all. Today we will be continuing our previous lecture, which is of CAE/CAM. Continuing that, we will start with your engineering data management system, where we will see how the data in an engineering system flows. First, what happens basically is, according to the marketing team, let's say any engineering organization, the marketing team will give you the market requirements of how the product is being. Let's say for we are considering any product, right? For any product, how the engineering data is being managed, the whole system, right? From a designer point of view, manufacturer's point of view, as well as the distributor point of view, right? First, in order to create any product, first what we require is basically the need of a product, right? How, in what way the product should be, and how well it should be required by the marketing team, right? So according to this, the marketing team or the people who are open to getting orders out or sales input out, they will be getting your requirements, right? They'll be feeding them into your computer systems, right? Let's say a bottle or a product is of required of this particular quantity or this particular quality for this particular size of a market, right? This is a size or is a volume of product that is being required. So according to this requirement, right, the designer makes a design which includes a conceptual design as well as a detailed design and drafts, right? So all these things will be done by a designer according to your requirements and fed into again system, right? Now next will be your planning. Planning in how well you can plan to get your product out. It includes your process planning, CNC as well as tooling. What is required, when is required, and how well it is supposed to be working. Next is your production planning, control as well as management. And last, after production is done, dispatch or invoicing. How well these should be distributed along the all the customer base. So all these things are fed up into your computer systems, right? By the individual contributor, they will be distributing the same. So according to that, what happens is the data will be managed accordingly by your sales team or marketing team, which processes your sales order, right? As the product is being done, as being distributed, according to that, sales will be processed. Then the design will be updated or managed based on the designer's requirement or based on the data that is being fed to your computer system. Next, drafting, right? After design is being finalized, the same thing, the same design is initiated with your drafts, right? To let the manufacturer know how well they will be able to create it. And your analysis regarding FEM is basically of how well the product works in a real time life. We can estimate the life of a product based on the type of use as well as the boundary conditions that we impose on it, which occur in real life. Next is your quality information, right? How well it should be made, right? At the final part, how well it should be maintained according to the standards that are according to which the product has been designed. Next, BOM information, which includes bill of materials, which states the number of pieces, right? The number of pieces of product that are required to generate one complete product, right? Or else it can also be called as a subassembly of individual components to form one complete new product, right? Next is your MRP2, which stands for Material Resource Planning. So according to the requirement, according to your production rate, how well the materials are required, how many number of quantity is required. Based on that, you are supposed to plan. Next, what you are supposed to do is you are supposed to study any changes that are required during manufacturing, during production, right? In order to ease in manufacturing, how well can you be able to produce a particular product? Next, what you will be supposed to do is you are supposed to create a jig as well as two new products. These two are not directly related to product, but these help in supporting of holding as well as uh, product increasing the productivity of your production of your product. Next, scheduling. Scheduling is basically how what comes first, right? Depending on the type of product you are developing, the scheduling can be done based on the requirement. Next, work input control, right? Work input control. What are the inputs that we require or that are supposed to be given in order to successfully create or efficiently create a product out? Based on that, we are supposed to give your inputs in. Next is your dispatch management, which is nothing but what is the priority point or what is the priority order that is supposed to move forward according to the in accordance to the orders as well as your uh, production rates. The dispatch management controls the rate at which the products are being distributed or released all over the distribution center. And last is your order processing. As the order is being dispatched, what is the additional term, what is the additional order that you are processing. In the same way, how well these are getting reference, right? For any assembly, let's say assembly gets updated from one point to other point over a period of time. So based on the issues that we encounter, right? Based on the issues that we encounter, these assemblies gets updated and these will be stored in order to maintain a certain history of or a certain record of where the product has been developed. Now each assembly has number of sub assemblies as well as part, right? Each part will have separate issues that is secondary. Each assembly, let's say for assembly A, is made of and sub-assemblies part B as well as part C. Again, sub-assemblies are again further made broken down into your sub-parts. Right? Now, each part or each assembly will be having a separate list. List of data for the number of parts that is using and from where the part has been taken references from. Now, for example, if you take part C, because every last one will be getting to your final part. So part C, what does the data file contains? Basically, are your properties. Properties of this particular part, which includes mass, inertial, and many more. Right? Next, what are the 2D CAD files? Particularly your sketches that you are used to get your part out. Next is your DTP files or your text files, right? FM files, basically your analysis files. The 3D CAD files or 3D model files or draft files, and NC is for manufacturing perspective, right? For any part that we assume was a basic functionality, these are the sub sections or sub files or sub data sets that should be available while creating an assembly or any part of. Now, these data sets are referenced according to your major part or major product individually, right? Let's say for considering for product A, you're going for part C, which is somewhere around here, right? Under this part C again, there will be sub clauses for where all this data is readily available to consider wherever as it is necessary, right? Next, we'll go for your transformation of geometry. Under transformation of geometry, we will be having four: translation, scaling, reflection of mirror, or rotation. Before that, we'll discuss what do you mean by transformation, right? Any geometry, let's say, if it's a pen, right? It's a pen that we can see. Now, this pen has to be transformed or manipulated to a newer form or moving it away. In transformation, also, there are two kinds basically. First will be to move or reposition the object that is being on the screen. Or second is to duplicate the object, right? It means to keep the original itself as it is and copy the same to other to a newer position. Now in this we will see both. First we will see the movement is only to reposition a body from one point to the other point. First is nothing but your translation. Under translation, what you will be doing? Translation means repositioning an object in parallel to your Cartesian system, right? For example, this an example for your mouse, as we can see here, the translation, right? This point is a base point where this will be your x and this will be your y, right? And this complete geometry is fixed. I mean to say, the complete geometry is constrained. Means it's been completely well defined so that or it will not move or deviate as or when required. Now, you know, in order to move this mouse or this model at a certain direction horizontally, right? First, we can discuss horizontally. Horizontally means in the direction of x. What we are supposed to do? We are supposed to add a small amount of x through which it is supposed to move, right? So this translation takes place from the origin, right? Origin to your reference point on the object, then addition of a small amount of value or the length in which the translation is supposed to happen, right? In a similar way, if you want to move it vertically upwards in the direction of y, right, you are supposed to add a small amount of y, right, in the direction of y from the same reference point to move it up. Let's say if you want to move in an inclined manner, at that time, as shown in the figure, you are supposed to add a set of small change in values of x as well as y to rotate or to move, particularly to translate the object in a certain point or certain line, right? These differentiation values are known to us, right? Based on these values, what we'll be doing, we will be pushing up your geometry away, which you can see the initial point. Let's consider the initial point is A and in this A dash, right? Point A and A dash are parallel to each other, right? This parallel condition will be maintained along wherever we are going through. Next is your scaling, right? Scaling is nothing but the, with the consideration of small factor, let's say less than 1 or greater than 1, depends, we are increasing the size, right? We are increasing the size of an object. We are not altering the dimensions, we are not altering the faces, edges, everything. We are changing the dimension, no, sorry, not dimension, the scale, or we are increasing the magnification factor for a particular object. To be precise, this is my object A, and this is my object A dash after magnification. So, from my Cartesian system, 0 to 0, right, by multiplying my object A with some small scaling factor, which can be either less than 1 or greater than 1. If you are going for less than 1, it will be reducing, and if you are going for more than 1, it is magnifying, as shown in the figure currently. So, if you are multiplying a factor which is less than 1, for example, it can be zero point 0.5, zero point 0.8, zero point 0.1, anything which is less than 1, then the object gets reduced itself in the factor of zero point 0.1, if you are considering zero point 0.1, for every dimension or every face that you are shown up in the original figure, right? If you are using for magnification factor, for example, it can be 1.5, 2.5, 3.5, anything, or 1.2, right? From the original size, it will get increased or magnified in every aspect at a factor of 1.2, right? Now, in this case, in both the cases, the scaling, the origin remains same, right? The origin remains same, only the magnification factor in the both direction of x as well as y will change parallel, right? Next will be your reflection of mirror. Under reflection of mirror, if you are considering an object, right, an object A, right? Wherever the object lies, it can be on the line, away from the line, or at a certain distance specified to some object. It gets copied or it gets reflected back from an axis common to both. For example, if I consider x as an axis as as a reflection line through x, whatever the object is there, right? Whatever the object is there gets reflected back, same as your mirror, with whatever the distance you are getting. For suppose, if there is no distance here, this 25 becomes 0, this also becomes 0. The object lies here at x. Again, the newer object, whenever you are using a transformation feature called mirror, then a newer object will also emerge right after your mirroring axis or mirroring line, right? These are according to your Cartesian plane. Same thing happens if you're going for y. Now, the same objects gets reflected in this manner, right? Right. This will be an example for if you are mirroring it on y-axis or x-axis. This is the case. Now, next is your rotation, right? You already made an object, right? You already made an object. Now you want to manipulate it in such a way that it should be rotated at some certain angle, but you should don't want to disturb particular geometry completely. So in that cases, what you can do, you can basically select a center through which it's supposed to rotate. Next base point from where it is supposed to be rotating, and the angle through which it is supposed to rotate. Right? Let me come back. This I will come back again. So selecting an object with a fixed base point from measuring from the axis and rotating along the length or along the angle of inclination that you require it to be changed. Then you can transform the object to a degree or a certain angle that we require. Basically, if you want to keep both as a separate part, you can use duplicate command in all the four transformation features, where you can copy or keep the original image or original model as it is and create a newer model with same features, right? Now in this we'll discuss a small thing, basically what is the data that is required to perform this particular transformation, right? Whenever you want to transform an object from point A to A dash, as we will discuss here, what is the data you need is what is the change of length, what is the change of length in the direction of x as well as y, right? For example, I'll be selecting this point, my origin, sorry, not my origin. I'll be selecting, I'll be selecting my point, and I'll be this geometry is completely constraint geometry, right? This constraint geometry I'll be giving, which already have predefined values of x and y for a particular base point that I'll be considering, for which I want it to be moved, this base point to be moved in accordance to with my, right, these two. So my newer base point will be defined in here, right? Newer base point, according to which all the other points, all the other points of the model is being defined, right? Next, if you want to go for a scaling factor, it can be either less than or greater than 1. The whole model gets multiplied by small scaling factor, right? It can be less than or greater than 1 depending on the type of scaling that we require. While reflection, what we are supposed to do is for reflection, we are supposed to select a model, right? Or the face, anything, whatever you want to get reflect, you can select, and then you can select an axis through which it is supposed to be getting reflected, right? You are supposed to select an axis through which is supposed to be getting reflected. In this case, if I select my y as my reflecting line, at that time the model gets formed here, right? If I get my x as this is the model that is being formed. Now, while coming for rotation, what you're supposed to do is you're supposed to select the center through which it is supposed to rotate, then a base point through which it's supposed to be lifted up, and the angle at which angle wherever your new inclination should be. On selection of all these three, you can clearly rotate an object. Now, continuing the transformations, there are a few more terms regarding transformations we are supposed to discuss. First is concatenation of transformations. For example, as we have discussed, what translate, right, rotate, mirror, or reflect. Next is my scale, right. We'll remove the scale a bit. We'll keep a scaling a bit. In any CAD modeling, right, these three are major transformation features that you'll be using, right. Sometimes either one, multiple number of transformations are required to get your final position or final repositioning of your final transformation of your object. For example, I want to create a translate as well as mirror, right. I want to use multiple transformation features, particularly translate as well as reflect, to get my final product out or oriented mirrored in such a direction. For that, what I can do is basically I can use concatenation. Basically, it's adding adding multiple transformation features. Multiple transformation features, right. Parallelly, if you're performing a complete transformation for an object to be for the final thing, then you're calling it as concatenation, right. Next is your homogeneous representation, right. Now coming to this, reflect as well as rotate, these two are represented with respect to few angles if there are any. Whereas for translate, only x and y change is required. So in order to make them under single representation or same representation, for that what you'll be doing, you'll be converting your translate part or translate transformation into small matrix form, which is very similar to your other transformation features, so that the representation of this whole set of transformation tools will be as effective for transforming your 2D as well as 3D geometries. Next will be your rotating around an arbitrary point. For this, we'll take a reference from your previous point. Right? In this case, rotation, this is your origin through which you are rotating your object. Suppose I want to transform, I want to move this along this point, which is defined as x comma y, point A. Right? Through point A, which is an arbitrary point, not on the Cartesian system, away from the Cartesian system, which I want to rotate at a particular angle. Now, when I want to consider this as my point, then I'm supposed to consider this A point as my first, right? First, a center through which it's supposed to rotate. Next, the base point through which it is supposed to move, and the angle through which it is supposed to rotate, right? Whenever you are rotating this, the Cartesian point, which is from 0 to 0, changes to a small arbitrary value x and y, where x and y denotes your basic point through which you are rotating. Right? In a similar way, reflection along an arbitrary line. Right? This object, as the same example, we are reflecting along the x or y, right? I want to reflecting along a line, right? If a line has been drawn, let's say A and A dash, right, through which I want it to get reflected. So whatever the spacing has been there, if there is no spacing also, that's secondary. While selecting the object, and this will be your line of reflection, then you will be getting an object similar to what I am drawing here, right? Right. This same spacing will be maintained wherever the line has been made. Now this is your Cartesian line. Now coming to this is your right. According to my line, what I will be doing, I'll be changing my line. Depending on the final transformation of my object, I can able to redo that. Last is your scaling. Scaling about an arbitrary point, right? Now under the scaling, right, as we discussed earlier, the scaling from an arbitrary point. If you are scaling this at this particular point, then the scaling factor applied from the point will be different if compared to your Cartesian system, right? From your Cartesian system, you can see the scaling factors applied uniformly, whereas depending on the type of point through which you are starting your scaling factor, the size as well as for the object changes, as well as the orientation of the object will also change. And the last is your 3D transformations. Under 3D transformations, whatever we have done under 2D, we are applying the same for your all the three axes, which is for x, y, as well as z. Simple to your Cartesian system. Under 3D transformations, the data change occurs in the direction of x, y, as well as z, in which all the data that is necessary for your 3D transformations will be derived from your basic 2D transformations into or as a dot product of the z. Not only in the terms of z, sometimes if the 2D transformation occurs in the direction of y and z, then the factorial multiplication will be in the direction of x. In a similar way, all the transformations will occur.
Like, share, and subscribe. Hit the bell icon for more updates.